Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Functions, Basics. Concept number 7, domain of a function from an equation. The odds of someone doing exactly what you tell them to do is slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. If I could stick every single math student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. So inbox me at memedicine@gmail.com to get your healthy dose of Algebra 2 by ordering the complete cram session. You have lots of friends, peers, classmates, and our colleagues who are taking Algebra 2 along with you as well. So tell them to inbox me at memedicine@gmail.com so that they too can order the complete cram session. Let's delve into the concept. Function basics, domain. What are the 3 basic rules for finding the domain of a function from an equation? Definitely press pause if you need to, and I'll give you a moment to think. All right, so in the preceding cram session, we determined that the domain of a function from a graph can be ascertained or determined by visual inspection. That's basically looking to find all the values, or the x values rather, where the graph exists. Okay? The domain of a function is the set of all possible values of the independent variable, usually called x, for which the function exists. And that independent variable can usually be found along the horizontal axis of a coordinate plane, okay? There are 3 basic guidelines for determining the domain solely from an equation, and we're going to look at 3 different examples. The first guideline is denominators cannot equal 0. So let's use the example of the reciprocal function 1 over x. So here goes our equation 1 over x, and we're still going to use our handy dandy graphing calculator to see why the denominator x cannot be 0. Okay? So this is the parent function. It can take on several forms. We input this parent equation into our graphing calculator, and then we pull up our table, which shows the set of x and y values, basically, or coordinate pairs. And we see that whenever we input an x value from our domain, this is our domain, this is our range, of 0, we get an error message. Basically, nothing exists there. It's undefined, but anything outside of 0, it can be negative or positive, we have an answer. So let's take a look at what this would look like on a graph. So here goes our reciprocal function graphed 1 over x, and we see that at 0, at the origin, we have a vertical asymptote because nothing exists in that region. Hence, even if we didn't go into all this, the graphing, we know that the denominator cannot be 0, so the domain is x such that x is not equal to 0, but it can be anything else. The second guideline is that the square roots of radicands must be greater than or equal to 0. Okay, so let's use the example, the square root of x. I said the square root of radicands, I meant square root radicands. You can have cube radicands, the fourth root, radicand is just an expression or an equation with the radicand or square root sign. It's technically not a square root sign, only if you're taking the second root. You could have the fifth, sixth root, so many different roots to take. Anyway, that's an aside. And again, let's input this equation into the function screen on our equation grapher. And when we pull up the table of ordered pairs, we see that for anything 0 and up, or greater than or equal to 0, we have an answer. But anything less than 0, we get an error reading, meaning there's something wrong and nothing can exist there. okay? And let's see what this looks like on a graph. We see that when we try to put in a domain value or an x value of -1, we don't get anything for y. For the equation, the square root of x, okay? It's approaching, you know, the negatives, but it has to be great. It starts at 0 and basically increases, all right? And I don't want to mislead you into thinking that it's totally off to have a negative underneath the radical sign, but that's a whole nother cram session. But for right now, for where you're at in Algebra 2, we just don't even think about it. You could factor out the square root of -1, and then you would be getting into the realm of imaginary numbers. This value is assigned the value I for imaginary. So whenever you see an I, -1 square root of -1 has been factored out, but we're not dealing with that right now, okay? You can purchase the entire Algebra 2 cram session for more information on this. The third guideline is this: arguments of logs must be positive. When I say arguments, I mean the results. So the y equals the log base 9 of x is going to be our example here. And remember that all logs are actually exponential equations. They're just inverse exponential equations. This is basically saying y is the exponent that you raise base 9 to get the power of x or the result of x. People usually call the exponent a power, but the result of an exponential equation is actually the power, okay? So let's see why the arguments of logs must be positive, or let's just prove what will happen if it's not the case. We input our equation, log base 9 of x here, and then we pull up our table of ordered pairs, and we see that for anything 0 and less, we get error readings. Okay, that means nothing exists there. And when we take a close look at our graph, it's almost approaching an x value of 0, but it never actually touches. Now, x can be 1. These are increments of 0.5. At that point, you'll get a y exponent of 0 because any base raised to the 0 power is just going to be 1. But don't get that confused. The actual result is not going to be 0. It's going to approach 0, try to get there, but never actually quite make it. Okay? All right. Yeah, so that's pretty much it. Definitely inbox me to purchase the entire cram session, and good luck studying. I know you can do it. If you don't have time to sit through this entire series, then play it on double speed by coming over here, clicking on the settings wheel somewhere over here. You'll see a normal selected. If your speed is on normal, you can just go ahead and click the drop down and select 2, 1.5, 1.25, whatever your speed preferences, okay? All right, thanks for tuning in.